Hello, everyone. Welcome to today's Kubernetes Masterclass, brought to you by Rancher, now a part of SUSE. I will do a quick intro and go through some housekeeping items. As you can see, today's topic is a seamless approach to Rancher and Kubernetes upgrades. We have a couple great speakers today. My name, if you guys are familiar with our classes, is Connie Lin. I'm now a global events manager at SUSE, previously Rancher. Our main speaker today is Matt Mattox, principal support engineer at SUSE, and we also have Lucas Ramage, support engineer at SUSE, helping with Q&A today. Do you guys want to say a quick hello?
Hello.
Hey guys.
Hey Matt. Hey Lucas. Couple details here. Our master classes run about 45 to 75 minutes. We do have a total of 90 minutes scheduled. So if you have questions, we'll keep it going. If you have a question, you can pop it into the questions tab on your GoToWebinar panel. It will all be done via the text chat. So Lucas and Matt will do our best to answer them throughout the presentation today. We have a masterclass channel on the Rancher users Slack. So if you have not joined yet, head to slack.rancher.io and you can feel free to ask questions there as well. And that obviously will be available following this webinar. So if you don't get your question in today, you can pop it into that Slack channel. All right, and that takes us into the presentation, and I will hand it over to Matt to kick it off.
Hello, everybody. I'm gonna pre-apologize. I got a little bit of a cold, so my voice sounds weird. That's the reason for it. We're gonna jump right in. So this is just a quick overview. So some of the areas that we're going to focus on today. Just so you know, there is a GitHub that has all this text and scripts in a nice text format available here. This will get sent out as part of the slides as well. So don't feel like you need to take screenshots of commands and try to type them out really quick. They're all available for copy and paste in here. So real quick, some terminology, just so that we're all on the same page. The first one, of course, is the Rancher server. When I say that, this is where the Rancher UI runs. This is our orchestration engine. Some people call the nodes Rancher server, but in reality, it's the Rancher pods themselves. The other big one is RKE, or the Rancher Kubernetes engine. This is the tool that Rancher built to deploy Kubernetes clusters. This is also the same tool that runs inside the Rancher server to deploy clusters that Rancher manages. And that leads me into the local, or what we call the upstream cluster. This is usually the first cluster you built. This is where you deploy Rancher and kind of bootstrap your environment. But we normally just call it the local because that's what it's named by default. But some people call it upstream. And then, of course, downstream clusters. These are clusters where your actual applications are running. And generally speaking, these are deployed via Rancher, but could also be deployed via RKE, but then Rancher manages them. So when I usually am working with a customer to plan out an upgrade, these are my high-level rules that I follow. And mind you, these are very generalized rules. They're not really version specific. They're more design of a general rule. The first one being, don't rush an upgrade. I can't count the number of times that a Sev1 has been created because somebody was rushing. Somebody rolled something right into production and didn't test it in a lower environment, or typoed something. I mean, there is not a lot of safety guards in place as far as Kubernetes, and you can very easily break something if you're not paying attention. So please, please, please take your time. You will save yourself tons and tons of heartache. On that same note is, don't stack your upgrades. Too many times I've had customers that did a Rancher upgrade and a Kubernetes and an OS upgrade and an application deployment all in the same change window, and we have no idea which one broke what. So then we have to roll them all back, and that's just not a good day. The other one is good backups. Backup. Both a Rancher and Kubernetes upgrade rely on backups as your rollback maneuver. So it is very important, and in newer versions of Rancher and RKE, backups are turned on by default, but it's very important that you have backups, and no backup is worth anything unless it's been tested. So make sure you test your backups. The next big one I always get is, what order do I upgrade? The order that I always follow is upgrade Rancher, upgrade Kubernetes, then upgrade Docker. As far as the Docker version, we're not too concerned about that. We have a support matrix, which I'll go into a little bit later. That one can kind of just be managed by your OS team, and we don't really care too much about it. Of course, the next one is always have a lab environment. Have a lab, something that you can test these environments. This is different than dev. This is a lab environment that you can break Rancher, you can tear it down, spin it back up, and app teams don't know nor care that you're doing anything in there. Again, this is more for comfort. You should be treating Rancher like any other application in your environment and going through a standard release cycle. The other one, of course, is release notes. Every single Rancher release and Kubernetes release that we release has release notes that call out any major bugs, any known issues. They're usually very detailed around any gotchas that we know of. They're also very well tested by our QA team. And sometimes there is additional notes such as, hey, you need to apply this additional change before the upgrade. The other thing, and this is sometimes controversial, is the CIDC. So anytime that you're doing an upgrade, we don't want things changing in the middle of an upgrade. It's not an absolute requirement, but it's very helpful, and it has saved a lot of heartache by pausing any pipelines during a deployment, during an upgrade. For the simple fact that we don't want, in the middle of an upgrade, we interrupt somebody's pipeline and it breaks their application and they come yelling and screaming at us. So just, again, it's a recommendation, but please pause your pipelines. The next one is version. So a little bit of a disclaimer here. Rancher technically is tested and validated to jump 2 versions. So you can go from 2.1 all the way to 2.3. That is supported and allowed. But as far as stability, mind you, all these rules are built around being very conservative, with uptime and availability being the #1 goal. So we encourage you to take smaller steps, such as going from 2.1 to 2.2 to 2.3 to 2.4 to 2.5. It does take longer, but you will thank yourself for the long term. Same thing with the Kubernetes versions. There is nothing stopping you from going straight from 13 to 19 in RKE. RKE will let you do it, but you're going to have a bad time and things will probably break and you'll be on a support call with us. So again, it's best to kind of take those slower steps. As far as this one, the rule of 2 is okay. We don't need you to go to 13, 14, 15, 16. It's okay to skip every other one. The only one I would call out is 16. It's kind of a big jump, so we tend to ask people to stop there because that's when stuff starts getting deprecated. And then as far as RKE versions, it's not really an issue once you get to version 1 or higher. But if you're on older versions of RKE expects you to walk through each version one at a time as far as the families. So normally when a customer comes to me and says, hey, Matt, I would like to do an upgrade, one of the things I do is I schedule a meeting with them. And at the end of that meeting, basically, I give them enough information that they should be able to create their change control with their change team. Again, mind you, these are very generalized rules. These will differ based on your environment. But as a rule of thumb, 30 minutes to do a Rancher upgrade should be more than plenty. With additional 30 minutes to do a rollback, and we'll go into more details around those. Kubernetes, I tend to say needs about 60 minutes. Larger clusters can, of course, take longer. 1,000 nodes are going to take a lot longer than 3 nodes. So do test and plan accordingly with that. The other big one I have is impact. So the Rancher upgrade itself, as far as when you do the upgrade, the only thing that's impacted is Rancher itself. Now, your apps continue to run. They don't know nor care that anything's happening. Rancher can be on fire and your app should still continue to go on and nobody even notice. The only thing that is impacted, and again, this goes to my earlier comment, your pipelines. So if you have kubectl pointing to Rancher and being proxied down to your cluster, well, now I'm going to interrupt that for 30 seconds to 2 minutes while Rancher itself is restarting and WebSockets get disconnected and reconnected. We don't want that to happen right in the middle of somebody's pipeline. So that, again, that's why we ask that they be paused. Same thing with when you upgrade the local cluster, the cluster where Rancher lives itself. Again, it's part of zero downtime upgrade, so the cluster never actually goes down. It's a rolling restart process, but ingress controllers will recycle, which drop connections, which then have to get reestablished. And you have about a minute or two while the Rancher UI might not be unavailable. And as far as downstream clusters, now this is where it gets super important. You test this in your environment. When you were upgrading a downstream cluster, depending on your version, you might have to restart your ingress controllers and you might need to restart your overlay provider. It's done in a rolling fashion, so it's done only a certain number of nodes at a time. It's minimum of 1 node or 10%, whichever one is less, whichever one is greater, sorry. So there is a slight network blip when that happens. Your apps ride through it. They should have no idea anything's happened, except for a few seconds, the network was just unavailable. Your apps don't get restarted. They shouldn't know anything's happening. But just be aware for certain sensitive applications, you might need to take a downtime as part of that. So again, that needs to be tested. And then that brings me into maintenance windows. Generally speaking, the Rancher upgrade, no maintenance window, just pause your pipelines, go to Jenkins, pause it real quick. Same thing with your local cluster, just pause your pipelines. Your downstream clusters, especially in production, we usually do recommend picking a maintenance window or picking a quiet time. Just when, if 502 requests go up by 1% for 15 minutes, you're not going to have a manager come running at your desk. Don't do it in the middle of trading in the middle of the day. So generally speaking, a quiet time is usually plenty sufficient. So this is prep work. So I normally do a lot of this work either the day before or a couple hours leading up to the upgrade, depending on the environment. This is more of just a sanity check. We don't want to upgrade a cluster that's currently broken. We want to upgrade healthy clusters. So these are, and I'm not going to go too deep into these details. This is more just looking at the cluster, make sure everything looks healthy. We're going to go into the system namespaces, make sure all the pods are running and they're healthy. Want to make sure that overlay is not broken and there's some underlying issue that we don't know about. So it's just more of logging in and making sure there's a sanity check. The RKE, again, back to my backup statement earlier, make sure you have backups and validate they are working. The worst thing that can possibly happen is you do an upgrade, don't have backups or have invalid backups that don't work. And at that point, we're pulling in engineering because we're going to have to manually try to fix it. And we can't even guarantee that it'll be fixed at that point. And then, of course, the K3S note, this is more just a note. K3S has a slightly different backup mechanism, so follow the documentation there. And then it's not really an issue anymore. It's more for older environments. We had an issue about a year ago with certificates expiring after a year. So environments would be running fine, and then suddenly they would do an upgrade, and oh wait, this certificate expired 6 months ago. So this command, of course, will check your certificates to make sure they're valid. That's not really an issue anymore because we went to 10-year certs, so it should just never be a problem. These are the certificates that run Kubernetes, not the SSL certificate that runs like the Rancher URL. Those are two totally separate certificates. Same concept, but different certificates. So the actual change window. Now, the actual change is actually pretty straightforward. You're going to do some Helm commands to update your Helm to make sure you have the latest charts. We're going to do one last sanity check, and I can't tell you how many times this has bitten me. Make sure you're attached to the right cluster. Simple get nodes minus O wide. Uh-oh, I'm accidentally connected to production, and I thought I was upgrading non-prod. Trust me, it's happened, and it's happened to me. Another thing is backups. So this is the command to actually take the backup. I take the approach of nobody ever got fired for taking too many backups, so I overtake backups. So we're going to take a pre-upgrade backup. So if the upgrade fails, we go right back to the step. We want this to be kind of as close to the upgrade as possible, just so that we're not losing any other changes in the environment. The next one, of course, is the Helm get values right here. So one of the things when you initially installed Rancher, if you were lucky, somebody documented that initial install command. It has all these different flags. Helm will, of course, let you set invalid flags. It's not going to actually check that's a URL. It's not going to check that the cert's actually there. So the get values will show you what is currently set, so you can build this Helm upgrade. And then this is the actual command for doing an upgrade. The nice thing about it is this is also your install command. So if you're smart, you will save this command because your next upgrade, just change the flag, change your version. 1 second. Excuse me. So when I need to upgrade to 256, when that comes out later this month, I just change that version and run the exact same command, and I'm back up and running. So document that command, save it in a file somewhere. We even have some customers that just make it like a Jenkins pipeline job. And so all this is doing is just a Helm update. So one of the things is you can, of course, run that rollout status to see where the current status of the actual deployment is. It's fairly common that it's kind of slow to start, moves really fast, and then takes its time on the last node. It's just the Infinity rules. Scheduler seems to take its time. So again, 30 minutes is more than plenty. It usually takes about 5 minutes. Most of that time is validating at that point. So the validation step. So after you do the upgrade, you'll make sure the Rancher UI loads. It is normal to get some errors when it first loads up, especially if you have caching. So sometimes clearing your cache and opening up an incognito window helps a lot. So assuming that the UI loads, we're going to go in, and the first thing we're going to do is we're going to look at the clusters. It's totally normal for some of the clusters to be inactive while they reconnect. Give them about a minute or two, and they should all reconnect. Any more than 3 minutes, then I'd start getting worried. But generally, 2 minutes is plenty fine. And then we want to run the same kind of sanity checks. We want to go in to kube system and cattle system, check the pods, make sure nothing's crashing, nothing's broken that we just can't see yet. And then as far as this one, yeah. As far as the cattle cluster agent and cattle node agent, so these are the agents that the Rancher uses to talk to downstream clusters. So that's when you do a Rancher upgrade, that's the only thing that changes on a downstream cluster is those agents will get newer Docker versions. Their image tag changes. So you will see those getting updated. Kubernetes and all that is unchanged. Nothing should actually change in the cluster except for those. And it's fairly normal, especially in large clusters, that those could take some time because it's a daemon set. And it's okay if it's taking 15, 20 minutes to run. The agents are very backwards compatible, so it's okay if they're not all done yet. The other thing that we want to check Oh, sorry. And then the one last thing I always do is after I validate everything and I say, okay, everything looks cool. I might have an application smoke test just to validate that they can do a pipeline. Is I take a closing snapshot or a post-upgrade snapshot. This is for if the next day I make another change and then that change breaks my cluster. Well, I don't want to roll all the way back to before my upgrade and have to redo my upgrade. I want to roll back to the latest snapshot. So this gives me a nice good point in time and a known good state that I can take. Again, nobody ever got fired for taking too many backups. So the backout. If you're a Rancher customer, please call us before you do anything. But the backout really is an entity restore. We're going to go into the Kubernetes database and we are going to roll the database back to a previous state. We're going to take the database down, we're going to remove the data, and we're going to inject old data and bring it back up and let Kubernetes reconcile it at that point. 2.5 changes this a little bit. I'm not going to go too deep into that because it's still in the, technically, I believe it's experimental. But again, this is why backups are so important. Because without them, you don't have a backup plan. There is no Helm downgrade. There's no, if you do a Helm, and just select the lower version, Helm will totally let you do it, but Rancher is most likely going to break. So having a good backup and also testing it, this is something I usually tell people to do, especially customers that are starting off. Do this in the lab, run through the restore, get comfortable with it, because the last thing you want to do is have sleepy 3 a.m. Matthew doing a restore for the very first time. That's not a plan for success at that point. Okay. And next one. Lucas, I see there's some questions about, what was the question about?
Hey, Matt.
Yeah.
The question was about our system upgrade controller project that we have on GitHub.
I'm not super familiar with that. I believe that's part of our new GitOps fleet stuff that we're doing. Long story short, I'm not a fleet expert, but fleet is really the idea that your whole environment should be controlled by a Git repository. And I believe that's part of it. I don't know too much about it, but that's a great question. If you post that in the user Slack, I'm sure we can find a good expert to answer those questions. And then I believe there was another one about something about an OS upgrade or something like that.
Yeah, we also had another question about where does Ubuntu upgrades and OS upgrades fit into our order for Rancher, Kubernetes, and Docker?
So, and I'm going to break this into kind of two answers. Ubuntu, just upgrade, do your other patching cycle. As far as how you do the upgrade, what I usually do is I tell people Kubernetes is actually pretty lenient. As long as you don't reboot all the nodes at the same time, they're usually pretty lenient about that. Some customers go through the process of scripting out like an Ansible job to drain the first node, take it down, apply patches, reboot it, bring it back up, uncoordinate, and then go to the next node in the cluster. That's the safest approach. Normally, if you just do a quick reboot, as long as everything comes back up, it usually is really good about reconciling itself and just running off. As far as applying patches, we always, of course, like you to stay very up to date. We have the Rancher support matrix, which lists out what OSs and which versions that we support. We're fairly up to date. Usually Ubuntu, whatever they're currently releasing for Docker, usually that's the one that we're picking as well. And then as far as Docker upgrades, I usually tell people just let your OS team handle that. Just yum update Docker and whatever your OS is providing. Usually that's more than sufficient, and usually it's going to keep it fairly well up to date. I hope that answers that question. Is there any more, or are we good to go ahead to the next section?
I have a couple more here.
Sure.
The first one is a pretty easy one. Can you change the Rancher server URL after you initially set up your cluster?
Yes. So it can be done. I believe we originally called it out as an unsupported thing. We have since found a way to do it. The reason being is that all the downstream clusters, they connect back to Rancher over that URL. Well, if we update that URL, now suddenly nothing can connect. So there's a process. It's actually one of our former colleagues, Patrick, wrote it before he passed. He wrote a tool that does that for us. So if you go to support@rancher.com, and in our articles, you just, I believe it's like change Rancher URL, and it walks you through the whole procedure and walks you through the script for doing that. Cool.
I had another one here. We mentioned RKE, but we didn't mention RKE 2. Do the recommendations for jumping versions apply for RKE 2, or is that going to be different?
That is a great question, and I would like to know the answer to that myself. RKE 2 is still very new as far as support is concerned. It's not really in our wheelhouse today. We do support it, and we do manage it, but it just doesn't have the maturity. We haven't gone through a bunch of RKE updates as we have done RKE 2. Again, that's a great question to ask in the user Slack, and I'm sure one of the RKE 2 guys would be more than happy to answer that question. Okay, I'm going to go ahead and finish up the RKE upgrade so we can get on to demos, and then we'll close with some more Q&As. So an RKE upgrade. So one of the key things, and I can't tell you how many times this has bitten us in the butt, have your cluster.yaml. A lot of times customers will build, a contractor builds the cluster and then leaves 6 months later, and then nobody has any idea where the cluster.yaml, and more importantly, the cluster RKE state. The state is all of the certificates, all of the information that RKE knows about that cluster is stored in that RKE state file. We have ways of recovering that, but make sure that to save yourself a lot of effort, make sure you save those. The YAML can just be put in the Git repository. A lot of customers, because the RKE state does have like secrets and certs and stuff like that in it. A lot of customers will just shove that up to like an S3 or an Artifactory or something like that. So make sure you keep those around. The other one is verify that you have SSH access. RKE uses SSH to basically talk to downstream nodes to be able to communicate. It creates an SSH tunnel. So make sure you have SSH, make sure you have keys. Make sure, like if you have an ops team, make sure that they have access to those nodes, and they need to be able to run Docker commands. With sudo is fine, but sudo without a password is the requirement. The other one, before you start, make sure you're upgrading a healthy cluster. Again, if a cluster is broken and you try to upgrade it, it might work, it might not. You're kind of rolling the dice there. It's better to postpone an RKE upgrade and fix a cluster than to try to upgrade a broken cluster. Again, that goes into making sure, and I actually use this command all the time. So what this does is it says, give me all pods that are either not running or completed. So you'll find pods like image crash loop back off, and these might be application pods, so you can kind of ignore them. But it's good to just look at the environment. If this returns nothing, that's good. The other one is your Kubernetes version. So one of the things is in RKE, if you don't specify the version, RKE assumes whatever the default for that version of RKE is, that's the version it's going to deploy. I personally do not like that. I want to be in control. I want to say, no, I want you to go to 117.6, Rancher 1-1. I want to explicitly tell it, because what I don't want is an accidental upgrade. Somebody upgrades my RKE on my jump box. I do an RKE up, adding a node, and I just accidentally upgraded my cluster. It might work, and nobody might notice, but it's kind of bad to explain that to the team if I accidentally upgraded something. So please, please, please specify your RKE version. And you can see your versions by running this command. Note, it's basically a lockstep. Whenever we release a Rancher upgrade, we also usually release an RKE version as well. So just be aware that you might need to go to a newer version to get CD patches and those kind of things made available to you. Next slide. Yep. So the change, again, it's take a backup, take a backup, take a backup, take a backup. And this is even more important on the Kubernetes because more than once an upgrade has gone south due to some unknown issue, and I've had to tell a customer, sorry, you don't have a backup. The data is gone. We can't recover it. And we've had to spend hours with engineering to try to recover data and try to rebuild. Save yourself the heartache. Take a backup. And also give your backups really descriptive names, just so that, again, 3 a.m. sleepy Matthew is not the smartest Matthew. So let's give him a little bit of an easy time by giving it a very descriptive name. This is what I was talking about earlier with the Kubernetes version. This will hard code that version. You're explicitly telling RKE, I want this version of Kubernetes deployed. When I go to do my upgrade, I simply just change that to whatever newer version I want to go to. A side note here is the air gapped. If you are air gapped and are self-hosting, there is extra steps that you need to do, such as pulling down the images. This documentation goes into very detailed explanation of that and gives you some scripts to do it. So I won't cover that here, but just be aware that air gapped has some extra steps in place there. The verification. So one of the things you'll do is you'll do an RKE up, and at the end of that, it'll say, okay, it's finished now. You'll do a kubectl git nodes -l-wide, and you'll see your Kubernetes versions. We have had issues in the past. It doesn't happen very much anymore, but a node will get left behind, and everybody's on 17, and he's still stuck on 15, and you need to investigate and see, figure out what's going on with him. We don't want to just assume that because that command completed successfully that everything's hunky-dory. Again, we want to make sure all their pods are either running or completed. And then same thing, again, what we're looking for is pods starting to crash, Prometheus crashing because we broke overlay because of this kernel bug or something to that effect. The cluster might be up, it might be available, but there might be other issues that we need to investigate. So do a sanity check, make sure your pods are healthy. A side note on this one, sometimes it might make sense to take a screenshot of this command before the upgrade and after it. So was that broke, was app team A broke before the upgrade and it's not the upgrade that broke them, that they were already broke ahead of time. So that's going to be very helpful. And the backout. You must do an etcd restore. Again, it's the same as the Rancher rollback. Is you do an etcd restore. There is no downgrading. Oh, that should say RKE. There's no downgrading RKE. I don't even believe RKE will let you. If you specify an older version, I believe it errors out, unlike the Helm. So again, do an RKE restore. There's documentation here for doing it. One of the things I tell customers is, you give me an RKE snapshot and you give me a cluster.yaml, and even now just give me the RKE snapshot, I can rebuild your entire cluster from scratch. I should spin up brand new VMs, we can load in all the data and rebuild. As long as I have that snapshot, I'm golden at that point. So please, please, please have your backups. So we're going to shift gears and go into demo. So the first one we're going to go over is if your cluster.yaml and cluster state are missing. Let me move my screen over here. Okay, you should be able to see my screen. So in this case, I'm in Labai. Yeah, okay. I'm going to be very bad, and I'm going to get rid of my cluster state, which is this is the file that stores the actual state of what the cluster is currently in. I'm going to get rid of my kubeconfig file, so I can't kubectl to the cluster. Get kubectl, get nodes. Nothing works. It's not available. I just renamed my cluster.yaml to org just because I don't want to recreate it by hand. But again, we're going to assume that that's gone. We're going to assume that it was on some contractor's laptop and he's pieced out. So the very first thing we're going to do is we're going to hop on a control plane node. And again, you might need to do some investigation on where these control plane nodes are at. And I've pre-baked it. Again, these commands are all in the doc. So I pre-baked this script onto the server. One of the things this will do is this gives us our kubeconfig. So any control plane node on a Rancher cluster has a copy of the kubeconfig file. Basically, think of this as the admin kubeconfig file that we can use to get into Kubernetes and be able to restore service at that point. So now that I've created that on this node, we'll go ahead and SCP it down. And then I'm going to go in. One little quirk about this is it loses local loopback by default. So I just got to go in here, change that. And see now that I have that, I've regained access to my cluster. So that's good. So now the emergency is averted. I'm then going to run this script called the cluster YAML recovery. What this does is we store a copy of our cluster YAML inside the cluster itself. So as you see here, it went through, called into a config map and started pulling all this information and building my cluster.yaml from the recovery. Now, mind you, this assumes that the cluster is up and healthy and they are just missing those files. If it's not, we might have to take some extra steps, but this is super useful. Again, the whole contractor left and didn't save all this information. There's also extra stuff in here that some of the stuff you don't need, but the nice thing is now I can do an RKE up and I now have access to my cluster. One of the things, and I'm just going to go ahead and Control C this because we don't actually need it to go up. The reason this is so important is if I go in here and I misbehave and delete this and delete this, so now I just have my cluster.yaml file. If I do an RKE up, initializing Kubernetes cluster, Kubernetes is going to say, oh, I'm a brand new cluster. I need to create new certificates and I need to reinitialize everything. It doesn't know that there's an existing cluster out there. The scary part is sometimes this will finish and it looks like everything's cool and hunky-dory. The problem is all your tokens have been invalidated because your Kubernetes tokens are based on the certificate authority. Well, we've now just changed that certificate authority to a new certificate authority. So this is going to run for a couple minutes. So you might not know it right away. Again, it's super important to get those files. If you run into this scenario, you can follow the exact same steps to revert it back. We can go and grab an etcd restore, roll the cluster back, then run through those two recovery scripts and be able to recover that state and that cluster.yaml. We are changing this in RKE too, so some of this might be invalidated in about a year, but just be aware that this is how it works today. Yeah, I believe this will fail because Kubernetes won't actually, etcd won't come up. So I'm just going to leave this cluster broken. So let's change gears. Again, all the commands, everything is all stored at the GitHub link with I have a list of commands for setting up the demo and getting you into the issue, and then how to resolve the issue. This is a great tool for if you want to get comfortable with troubleshooting Kubernetes, troubleshooting Rancher. It's a great way to break it in the lab and then fix it in the lab when you're not sleepy. Okay, let me move this over here. Okay, and demo 2. This is the other common one we see with old Helm versions. So we see in some organizations, they'll deploy Rancher and then basically it's allowed to sit for a year or sit for 2 years because of other priorities. They only are allowed to upgrade once a year, whatever. So what I've done, and let me shift into lab B. So what I've done here is I've installed, let me show on the right cluster. I've installed Rancher using Helm 2. Now, let's say I installed the Helm as part of a package with my OS, and it got updated to Helm 3 without me knowing it and totally being unaware of it. So I go in here and I try to run my regular Helm upgrade command, and it's going to start hooting and hollering at me going, hey, I'm missing these annotations, missing these labels, etc. This is an artifact of the fact that this Rancher was deployed using Helm 2, and Helm 3 has some additional labels and annotations that it adds. Now, I've been a nice feller, and again, this is all in the documentation. I've gone through and mapped out all of the labels and annotations that need to be added to all of the different resources. So we just need to apply all those. And then magically, now Helm 3 will work. And I can go in here. Oh, wait, let me copy, paste. Again, all those commands, I missed something. It's under the namespace. Okay, I'll fix that later. Wait, let's say, yeah, okay. Yeah, so this is, oh, I didn't push the latest version. So I'll fix that before we publish. But yeah, so normally this would just add the additional annotation, and then it would let you do the upgrade. And then one more, and then we'll get into Q&A. And again, as long as it was deployed in Helm 3, it's not an issue. It's only when it was deployed in Helm 2. So if you have a Rancher 2.1 or 2.2, probably was deployed in Helm 2 back when it was originally installed. So you're probably going to run into that issue. The other one is a broken node. So back to my earlier statement, we don't want to try to upgrade a broken cluster. So I'm going to go in here. I think I left it broken. No, I didn't. Okay, 1 second. I'm going to intentionally break this cluster. So I have a 3-node cluster here, and I'm going to go into this one. And I'm going to Docker stop it. So I'm going to quote unquote kill this node. I don't actually want to power it off because I don't want to have to log in to the console and power it back on and all that jazz. I'm just going to Docker stop it. But now if I do a git nodes, within about 5 minutes or so, this will go as unavailable. So one of the things that we could run into is, let's say this was a physical box. So we might be waiting on parts and this, hey, we know this node is going to be down for a certain period of time. One of the things that Rancher does by default is it deploys a replica set of three pods with anti-infinity rules, meaning don't run the same pod on the same node. Well, if I have one of my nodes and my 3-node cluster is down, Rancher will never finish its upgrade because one pod will become unschedulable. Let's see if I can, yeah, okay, so now it's not ready. So if I come in here, I'm gonna set this as 3. I'm gonna do a Rancher upgrade. Oh wait, hold on. I did that paste in right. Oh, Okay, anyway, so what'll happen is it'll deploy the new pod to node 1 and node 3, but it can't deploy the third pod because node 2 is unavailable. In a ideal world, we want to recover that as soon as possible. If it's a VM, we want to reboot it. We want to have the OS team resolve it. If for some reason, let's say this is a physical box and that server is laying in a pile of ashes, so it's not going to be recovered, and hey, we didn't take backups of it. So all we're going to do here is we're going to tell Kubernetes and we're going to tell RKE, hey, this node's gone, and we're going to do that by simply just commenting it out. You can delete it. I like to just comment it out. And we're going to do an RKE up, which tells RKE to reconcile the cluster. It's going to go through and it's going to say, okay, I'm removing this node. If that node is still up and available, it will try to clean that node up. This will, of course, time out because Docker's not there. I shouldn't say Docker's not running there. So it will eventually just give up and say, okay, you must be dead. I'm going to remove you. Yeah, see, it's trying to call out to Docker and it can't right now. So eventually it will clean it up and you'll have a cluster of 2. Now, do not leave that cluster in that state. This is purely for emergencies. If you're rebuilding a node, it's take it down to 2, then immediately bring the third node, bring a new node online to replace it. Do not leave this for any length of time, because right now, not only do you not have quorum, you're actually worse, because if one of them fails, you're going to go split brain and it has no idea what to do at that point. So it's very, very important that you bring that new node back online. And also, so one of the things that we did is because the node's down right now, we haven't had a chance to clean that node up. So if that node comes back, it doesn't know that it's not supposed to be part of the cluster, and it's going to start reaching out and trying to do things. So it's preferred, especially if it's a VM, just delete the VM, get rid of it, get it out of there. If it's a physical box, maybe go out there and pull the NIC and run our cleanup script to remove all the Kubernetes services, just so it doesn't start doing crazy things in the cluster. And that's another thing. If you Google Rancher extended cleanup, we have a cleanup script which will basically, it's designed to nuke a node and bring it back to vanilla. It takes all the Kubernetes stuff, all the Rancher stuff off of it, and brings it right back to just a vanilla OS so that it can be rebrought back into the cluster. Yeah, so if I come in here to make it nodes, you'll notice that 2 is no longer there anymore. And then, of course, let's say I fixed it. I would simply just go back into my cluster.yaml, clean that node, then rejoin it, RKE up, and it'll be back up and running at that point. That's also how you do node rehydrations. If let's say you're moving from rel 7 to rel 8, you would simply just add the new nodes and pull the old nodes out. Technically, you could do multiple nodes at a time. We recommend doing only 1 node at a time, again, for safety reasons. It's better to break 1 node than break 5 nodes. With that, I'm going to shift back to here. I think that's it for my demos. Yeah. So now Q&A. So Lucas, do you get any more questions for me?
I do. I have quite a few. All
okay.
right. So I've had a couple more questions about RKE 2. Somebody's asking about the upgrade path to RKE 2, and somebody else is asking about upgrading from RKE to RKE 2. Is this possible?
So I'm going to give you the official answer, and I'm going to give you the Matt answer. The official answer is, as of today, there is not an upgrade path because it's more of a migration. We are moving from Docker to Containerd. There's a lot of differences with it. It's not just a change the config file and call it done. Now, the Matt answer to that question, we have a number of large customers that have asked for that, and they have been very vocal about it, and I am pretty darn confident that we will find a way to make it happen for them. So if I had to place a bet, I'm going to say yes long term, but as of today, no.
Cool. All right. The next question I had to do with some of the confusion going around about the Docker shim being deprecated in newer versions of Kubernetes.
Yes.
Could you speak to that?
Yeah. Uh, so TLDR, it doesn't affect you. Long answer. So what happened is upstream Kubernetes said, "Hey, we're tired of only writing our APIs to talk to Docker. We want to make it so that other people can come in and replace Docker. You can replace Docker with your own version of Docker, and as long as you talk on this API layer, it's just a drop-in replacement." Um, so what they did is they basically said, "Hey, we're going to drop the driver that we were using to talk directly to Docker, and we're only going to talk through the new API." Now the folks over at Docker, they stood up and said, "Hey, we'll handle the shim." So basically, we're going to add a layer in there to sit between the API and the Docker engine that just takes care of everything. Ranchers also stepped up and said, "Hey, even if Docker drops this, we'll step up and we'll take it." Um, so it's you just don't need to worry about it. And I wouldn't even start considering it until like 1.22 because that's when it actually gets implemented. So it doesn't even go into effect until that. So you've got time, and even when it does come time, you don't have to worry about it because Rancher's got you.
Cool. I would also just chime in with my little 2 cents and point them at our documentation. If you guys have any questions about some of this stuff and you ask on the user Slack, we can definitely forward the official, FAQs and notices to you from there. All right. Another question that I had for Matt, it kind of had to do with basically like rolling updates and versus like manual upgrades. I'm not really entirely sure how to ask
Um,
this as a question.
if I understand it correctly, are they asking about? Okay, I'm gonna assume if they're asking about OSs, yes. Doing a rolling update is perfectly fine, perfectly acceptable. That's how I do my environments. Going through node 1, patching it, rebooting it, waiting for it to come back up, then doing node 2. That's fairly standard, and a lot of organizations just script that out. Call it done. Just keep CTL, get nodes, and a little SSH script to just walk through them slowly, giving yourself a couple minute breather between each node so for things to settle down. As far as like the Kubernetes side of it, so Rancher has what we call a zero downtime upgrade. So when we do an upgrade, we never take a single service offline. We never take the whole thing offline. So like when we do an etcd upgrade, so we're going to a newer version of etcd, we take one of them down while the other two are handling the load. We then bring that down, we upgrade it, bring it back up, rejoin, and then we take the next node down and we do it in a rolling fashion. Same thing with the control plane. The only exception to that is the worker plane. The worker plane, that's where we get the one worker or 10%, whichever one is greater, I believe it is. So if you have 100 nodes, Rancher will take down up to 10 worker nodes at once. And when I say take them down, it really just cordons them, meaning it pauses scheduling, so nothing new happens on those nodes. And then basically just cycles the Nginx pods and cycles the controllers, some of the other controllers, and like kproxy and those a few other infrastructure ones. Those are all customizable. If you Google Rancher zero downtime upgrade, you can customize that to your heart's content. Some customers say, hey, I'm okay with taking half my worker nodes offline because it makes my upgrades go a lot faster and I can get it done in my window. Some customers go the other way and no, I want to take one worker node and I'll just let it run over the weekend and come back on Monday and it'll be fine. So I hope that answers that question.
Cool. Can you switch from cert manager to a DigiCert CA cert once your cluster is up and running?
Yes. Again, go to support.rancher.com. We have a whole article about switching certificate authorities. You can go from self-sign to Let's Encrypt to internally signed to publicly signed. Anyway, as long as it's a valid certificate, that's all we really care. It basically follows the exact same process that we do for updating our URL, and it's for the simple fact that one of the things we do is we take our certificate authority and we take a checksum of that certificate authority and we pass that down to the container. So the container can trust that certificate authority. So all we need to do is go in there and update those CA checksums. So there's a document, I believe it's like Rancher cert change or something to that effect in there, and it walks you through the whole process.
All right. Do you know of a way to directly reference external charts with Helm 3 installs as opposed to Helm 2?
Way to directly external charts. I'm not super familiar with that, so I'm gonna have to say ask that in the user Slack, because Helm 3 really just runs as a command line. Because all Helm's really doing under the covers, it's taking a template file from the chart and then applying your answers to it, and then doing a kubectl apply to the cluster. Especially in Helm 3, we had Tiller and all that jazz before. Now it's just it's a client tool at that point. As far as the Helm built into Rancher itself, that one, of course, we definitely support external charts. You can bring your own charts if it's HTTP S or Git. It just works just fine. That's how we do our charts as well.
Okay. I think the last question I have here is, what about in the case of, I'm assuming on-prem, where you need to upgrade physical infrastructure and you need to completely stop all of your clusters? Do you stop the local cluster first or the downstream clusters?
So we have a doc. It's called Rancher a Complete Shutdown or something to that effect. Again, support.rancher.com, that walks you through this exact scenario of how do you shut down a data center. As far as do I take my local down first and my downstream down, doesn't really matter either way. In reality, like I do it all the time in my lab environment, where as long as all the etcd nodes come down roughly at the same time, that's all we really are super concerned about. What we don't want is 2 out of the 3 going down and 1 being left behind. But we have a doc that walks you through the whole procedure of how to safely shut down a Kubernetes cluster and then bring it back up in a safe and controlled manner. And it's been fairly well tested, both in the lab and with customers.
All right, cool. I did have a follow-up for the Helm 3 question. Basically, the user is looking to install the chart without doing a pull first. Basically like a one-liner, like a one-shot to install it.
Yeah, not to my knowledge. Like I know Fleet it does it separately. I wouldn't be surprised maybe if there's a flag that I just are not aware of. But as far as I know, there's not like a specify remote URL or something like that. There might be. It's a great feature request to push to upstream. We'd be more than happy to support that. Skips a step for us, but as far as I know, no.
Awesome, thank you. I guess here's another one. What about Ansible and scripting upgrades?
So as far as scripting upgrades, and the nice thing is as far as the local cluster is concerned, do I have one of my scripts here? It really just is that, RKE snapshot, Helm update, and then RKE snapshot. So we do have customers that's what they do is that is just a simple bash script that runs inside Jenkins. There's some wrapper stuff to get the SSH keys and getting the RKE states, like going and doing an S3 command to pull it down from a bucket and all that jazz. But I mean, as far as scripting it out, that is the script that I use to build my lab environments. I mean, it's just RKE up, snapshot, and then our Helm command. If you really want to go down the road of automation, I recommend looking at our Terraform. The Rancher 2 Terraform provider is covered under Rancher support. We have Rancher people that are actively maintaining it and updating it. That's what QA uses to build their lab environments, is they use our Terraform provider. This is also what Hosted Rancher does as well, for spinning up lab environments, spinning up customer environments. So that's a fairly well documented and fairly well interrogated tool. As far as Ansible in particular, I do not have any Ansible scripts, but it's just bash. There's nothing crazy that we're doing as far as that. As far as downstream clusters, I believe we can just call the API. There's an API endpoint, and you just specify the newer version, and that's about it. And then as far as automating that, we have customers that do automate that. There is some extra wrapping that needs to be done as far as safety controls. So do you kind of take the approach of, and again, I'm not gonna say any names, but one of my big customers that has gone down that route of fully automating their rollout process, where they just have a Jenkins job that they kick off, that runs through their environment and pushes out the updates and does it in an entirely automated fashion. It was a lot of work. We spent about 6 months getting it working and 100%. But now they upgraded close to 100 clusters in a weekend, with kicking off one job and then going home. So definitely you will get that payback if you invest the time in automating that. And as far as like the Ansible scripts, again, that's a great one. Put it in the user Slack. I'm sure somebody in the community has it. Ansible's not a small tool, so I'm sure somebody can point you in a good direction with that one. Is there any more questions that we have, Lucas?
Here's a brand new one, just came in. I'm not sure how to read this. So how safe is it to upgrade a kubeadmin multi-cluster?
Multi-cluster.
So I'm guessing I'm just gonna, based on how it's read, we talked about RKE clusters, but this is a cluster created with kubeadmin. So how would the upgrade process look for that?
So I'm gonna give you the Rancher answer, then I'm gonna give you the Matt answer. The Rancher answer is we do everything in RKE. Our RKE wraps all that around it. As far as like etcd, we do everything. It's hard coded that we only do one etcd node at a time. Again, etcd is a database, and it must be treated as such. You wouldn't take down 2 out of the 3 nodes in an etcd database. If we have some customers that have 10 etcd nodes. I wouldn't recommend it. 5 is usually the highest we recommend. But even with 5, I wouldn't take down 2 nodes at once. I could, but no, we always do just 1 node at a time. And we always take it down, test it, validate it, and when we bring it back up before we proceed to the other one. So again, I think that's probably a great community question. we just don't have the expertise with kubeadmin to answer that in a good fashion.
Well, thank you for a great presentation and the demo. Lots of great questions today. Head over to rancher.com to check out all of our products and projects. Everything is open source. And as Matt had mentioned several times, if you have any questions, head over to the Rancher user Slack. I believe we have channels on all of these products and projects, but if not, you'll be able to find somebody anywhere you go in that channel, in that Slack. So a couple upcoming events here. We have our February online meetup next Wednesday, February 17th. If you want to learn more about the new Longhorn release that came out earlier this month, sign up for that. You can find the link at rancher.com/events. And our next masterclass will be March 2nd, and we'll be talking about monitoring. So you can sign up for that class as well on rancher.com/events. And next slide, I think, shows a couple more resources. We have the training, intro training, which is a little bit more basic than what we covered today. And also, if you want to get certified to become a Rancher operator, you can do that at academy.rancher.com. And I believe that wraps it up. Thank you again, everybody, for attending. And thank you again, Matt and Lucas, for a great presentation today.
Thank you.
I hope everybody has a great rest of their day.